Hello, this video will be a Python program about matrices. So we'll be doing operations laid out in the sprint menu function here. I've already created my functions, but not the calculation functions. But in the sprint menu, if the user chooses one, we do matrix operations, addition, subtraction, multiplication, and division. And then we have obviously a second function that will be called if the user chooses that option to use one of the functions to do the computations of that. And then for number 2, we have matrix and scalar multiplication. For if they choose number 3, matrix determinant. 4 is for matrix inverse. And then 5, we solve a system of equations using matrices. So that is the main idea of this video or Python program, is we're going to be focusing on these 5 points in the print menu function. So what I've done here, I've also built main. I'm not going to go over it in detail. Main focuses on exception handling and flow and traffic of the code. So we will take input from the user, we will give them a choice, and then they'll pick one of the options from the menus, and then once they do that, we call those functions, do the computations. We have a Boolean variables that we set to true, and once the computation has been done, the exception handling is not needed there, then we will set the flag to false, and then we exit the program if they choose to, because we have down here an option to give to the user if they want to exit the program or not. If they choose Y, then it'll exit. Okay, so what I'm going to do now is I'm going to run my code, and we're going to check the exception handling of this program and see how we do. See if the exception handling works, so we can jump onto our main functions that do the computations of matrices. So I'm going to hit play, and then it'll give us the print menu that we talked about, and then we enter a value. Let's enter a value that's not an option there, 7. It says invalid input, try again, 1 to 5. Enter a string, G. It does the same thing, invalid input, try again. And then once we hit, say, number 4, it'll print something for us that is not a computation on matrices. So what I've done here, if I go up to my code, let's delete that. So these are the functions that we need to make. So we have matrix additions. It'll take 2 matrices, but now it prints cities right now in Siberia or cities in Russia. We need to fix that. So it says Novosibirsk if the user chooses number 1 and presses addition, or it says Krasnoyarsk for subtraction, Chita, Ulan-Ude, and then so on. So these are all things that we need to fix. I mean, it'll obviously the functions are called in main, but we print things. We don't do any computations, and they're set up correctly. We just have to change. All right, so with that said, let's go ahead and make our first function for matrix addition. It'll take 2 parameters, matrix 1 and 2. And matrix 1 and 2, before we do that, it is defined here. It's hard-coded. So if you like your own matrix, that's fine. We will change these matrices. There are other commands you can use, like reshape, and you can change the dimensions of the matrix and so on. But this has been hard-coded, and in my opinion, this is just fine, just doing it like this. But you don't have to. There are other ways to make matrices. All right, so let's make our first function matrix addition. So we're gonna delete this. Well, we can leave that on. We will be printing stuff, but we will change the print of this function. So it's not a city or anything. So matrix add, we can set this equal to matrix 1 plus matrix 2. And then for our print, we're gonna print here matrix at. Yeah, right there. So that's our first function. I'm going to do subtraction and division quickly because that's the same idea as the addition. But once we get to multiplication, I will slow down. All right, so the 3 functions have been made. Let's go ahead and run the program and see how we do. So we're going to hit play and then choose number 1. That's from one of the choices. And then we're going to choose addition, A. So our result is 1, 1, 7, negative 6. And let's go make sure that's correct. We have 4, negative 6, 2, 3 plus negative 3, 7, 5, negative 9. And that looks like the correct addition to me. All right, and let's check. Let's hit no and then check 1 for option B, subtraction. 7, negative 13, negative 3, 12. And that is the correct subtraction of these 2 matrices. It does matrix 1 minus matrix 2, but in our print, I didn't put that in because it just makes it ugly. It'll print and say matrix 1 minus matrix 2 is this kind of ugly looking matrix in the middle. So, and then for divide, we can hit option 1 and then D for divide. It'll do the division of these two matrices. So everything is working fine. So let's go back to our code and let's hit Y and exit this program. And let's go and fix the matrix multiplication. So here we need to make a variable matrix multiply, and we need to tell Python how to multiply two matrices. So the way to do this is np dot and then matrix 1 comma matrix 2, and that's how we multiply two matrices together. And then we're going to print matrix multiply just like that. And then I'm going to keep pushing through, and then we will run our code at the end. So let's make matrix scalar multiplication. So this one will take the parameters a, and then a is going to be a number, and then matrix 1 is defined in main. So what we're going to do is we're going to say matrix 3. You can name your variable anything you want. I just made matrix 3, so it's kind of easy for me to follow. It's 8 times matrix 1, matrix 1 like that, and then we print matrix 3. Instead of printing Perm, that's a city in western part of Russia, Asian Russia, but then instead of that, we will print matrix 3. And then let's go to our matrix determinant. We need to, here, we need to define a variable called determinant. And this equals, so a command called np.linalg, like that. So it's like a linear algebra and then det for determinant. And we will take that of matrix 1. That is the arguments here in our function. And we're going to print determinants. Print determinants in there, like that. And then matrix inverse, this will take matrix 1 as parameter. So here we need to say some things. So if, let's see, np.linalg.det, matrix 1. Okay, so for this function called matrix inverse, it'll take matrix 1 as parameter. So if the determinant of that matrix is 0, we tell the program to tell we say that the matrix's determinant is 0, so the matrix doesn't have an inverse. And I need to fix this. This needs to be, I didn't even close my parentheses there. Let's see, inverse. Okay, like that. All right. So if the determinant is 0, the matrix is 0. The determinant of the matrix 0. Else, the matrix inverse is inverse of that matrix. So that's the command that computes the inverse of the matrix, and then we print the matrix. All right. So let's make our final function. It is called solving system of equations. All right, so this is our solve system equations function of matrix 1 and 3. So matrix 3 is defined in main. It is an array. It's usually going to be it's usually going to be a column matrix. We're going to transpose from a row matrix using this command to a column matrix, and it'll only have one it'll have one column because we have x and y. That's it. So this would in first column it's x. This is 11x, and then in the second column it's y by itself. So that's what that function does. And then we borrow the same code. This is copy and paste from the matrix inverse. We compute the inverse of the matrix first, and then we multiply the inverse of the matrix times matrix 3, which is xy. And the reason to do this, we're solving for a system of equations, and we need to compute the inverse matrix and multiply by it to solve the system of equations that way. That's how we solve them. We will see why that's the case when we run the program. Okay, so let's do a matrix multiplication. These two matrices are from the textbook. They are 2, -1, 3, 4, and matrix 2 is 3, -9, 5, 7. Let's run out to our code. I'm going to make this bigger. All right. So I've already hard coded those two in there. So 2, -1, 3, 4, 3, -9, 5, 7. Let's run the program, and we're going to choose option 1 and letter C for multiplication, and we get the same answer as they did. Their final answer was 1, -25, 29, and 1, and ours is the same. If we go check 1, -25, 29, 1. All right, let's do another example. Let's do the one for determinant. Let's go to page 194 from the textbook. All right, let's find the determinant of this matrix here, -2, 5, 6, 8. So I'm going to hard code that into my main function as one of the matrices, matrix 1. So let me go back. -2, 5, 6, 8. -2, and this is 5, 6, and 8. And we're going to run the program. So choose option 3. And the determinant of the matrix is -46. Let's see if that matches the book's answer. And it does. Their answer is also -46 right there. All right, let's do a matrix that doesn't have a determinant. That's also in the textbook, I believe. All right, so what I've done here is I've changed our matrix 1 into a matrix that the determinant is 0. So let's see what this does. The determinant of this matrix 2, 4, 6, 12 is 0. So let's run the program and see that determinant. Hit number 3. It says the determinant of the matrix is 0. So we're going to exit the program. So let's now check the inverse of this matrix that has the determinant of 0. So let's hit play again and choose number 4 now. It says the determinant of matrix is 0, so matrix 1 doesn't have an inverse. So it'll let us know if it's 0, then obviously it doesn't have an inverse. But let's change it back to something that does have an inverse. Let's go back and put a negative symbol in front of it. Now it should have an inverse. Well, let's do an example actually. See from our textbook, see if we get the same answer. I'm going to go to page 210. 210, and we're going to find the inverse of this matrix. The first one, the determinant is not going to exist, so we're not going to do this one. So let's do this example B. We have 3, 1, 5, 2, so I'm going to put that in. 3, 1, and 5, 2, and then we run the program. Actually, let's save it first, and then run the program. And hit number 4. So the inverse of this matrix is 2, -1, -5, 3. See if they get the same answer. Yes, they got the same answer here. Over here. Okay. And then lastly, let's do a system of equations. I'm going to check one from the book. It's going to be on page 218. 218. All right. Let's solve this system of equations. 6x plus 2y equals 11, 3x minus 8y equals 1. So let's delete that. I've already 11 and 1 are ready for us. Matrix 3 is that matrix that is 11 and 1 that equals the system of equations, the value on the right side of those two equations. All right, so let us though change the coefficients of the matrix to these ones: 6, 2, 3, -8, and see what we get. 6, 2, and then this is 3 and -8. So we're going to save the program and then run it, and we're going to choose option 5 now. So I get 1.66 continuing and 0.5. Let's see if they got 4/3 and 1/2 for their answer. 5/3, sorry. So 1.666 is 5/3 and 0.5 is 1/2. So that's how we create a matrix operations and matrix computations using Python. Thanks for watching.